In this video, we are going to show you one way to construct the secant line of a unit circle.
First, we will construct a point. We will call this point C because it will later be the center of a circle. Highlight point C, go to Transform, and click on Translate. We want this point translated 1 centimeter at an angle of 0 degrees. Construct a ray from point C to the translated point. Construct a circle with point C at the center to somewhere on the ray that is not on the translated point. We will call this point that is on the circle and the ray point A. The distance from point C to point A represents a radius of the circle. So we want to make a line segment from point C to point A. We no longer need this ray, so we will hide this. We also no longer need that translated point, so we will hide that too. We will now construct another ray from the center of the circle to anywhere on the circle other than at point A. We will call this intersection point B. To construct the arc, we need to make sure that nothing is highlighted, then highlight point A, the circle, and now point B. Go to Construct and Arc on Circle. Now the circle has a dashed line everywhere except the section of the circle that is cut by the two rays. This part has a solid line. We also have angle BCA, which we will call theta. Now we will measure CA, which is the radius, and the arc length BA. First, highlight point C and point A, go to Measure, Distance, and now we have the measure of the length of the radius. Now highlight the arc BA, make sure only the arc is highlighted and not the entire circle. Go to Measure, Arc Length, and now we have the measure of the length of the arc. To find the measure of the angle that is created from the two lines, we need to divide the arc length by the radius. So go to Number, Calculate, and click on the measure of the arc length, then click the division symbol, and now click the measure of the radius. Now we have what the angle measure is in radians. We will go to Properties and change the label to read theta, so we know that this measure corresponds to the angle measure of angle BCA. We no longer need the measure of the arc length, so we will hide this measure. If we bring the point B halfway around the circle, it should be at about pi, which is around 3.14. If we bring B all the way around the circle, it approaches 2 pi, which is approximately 6.28. Now that we have our angle measure of theta, we want to graph this value and have it lie on the x-axis, so we can begin to graph the secant function. We want our graph to have one unit represent our radius, so it can be the unit circle. So if we highlight the segment CA, go to Graph, and define unit measure, we now have the coordinate system that is base of our circle, and whenever we adjust the size of our circle, our graph also adjusts, so that the radius is always one unit measure. Now we will plot the value of theta on the x-axis. We will highlight the value of theta, go to Graph, plot value on axis. The value should say theta, and the axis is the axis x. Click Plot. The new point represents the value of theta, so we will construct a segment from the origin to this point and color it green so we know it relates to the angle on our circle. Now we want to find the value of secant theta. Secant means to cut, so we need to find the value of the line that cuts the circle. We know that sine is a chord and tangent is a line that touches the circle only at one point. So to find secant, we should find the tangent line first. We will highlight point B and the radius CB, go to Construct, Perpendicular Line. If a line is perpendicular to the radius of the circle and only touches the circle at one point, then it is tangent to the circle. When we move point B around, we will see that this line will always only touch the circle at point B and no other point, so we know that we constructed the tangent line correctly. Now we will construct a line from C to A. The secant line will be the hypotenuse of the right triangle formed by the tangent line and the line on the radius CA. This is right across from the right angle B that was constructed by having a tangent line. The segment that is the secant is the segment that goes from point C to the tangent line. Now we want to click on the intersection between line CA and the tangent line. We will call this intersection point D. And now we want to create a segment from point C to point D. We will color this segment red so that it sticks out as the secant line. We know that the value of secant will only be positive in the first and fourth quadrants of our unit circle, so we need to find a way to calculate this positive and negative values. If we look at the x-coordinates of point C and point B, we notice that the x-coordinate of B minus the x-coordinate of C will give us a positive value only in the first and fourth quadrants. So we will highlight point B and point C, go to Measure, and click Abscissa, because this gives us the x-coordinates of those 2 points. Now we will go to Calculate and measure the difference between these 2 points. So xb minus xc, but we only want these points so that we have a positive or negative 1. So we'll calculate the absolute value of xb minus xc, all of this divided by the value of xb minus xc. Now the value is only 1 or negative 1, and it is 1 in the first and fourth quadrant, and it is negative 1 in the second and third quadrant. This is what we wanted. Now to find the value of secant, we need to measure the length of the secant line. So highlight line segment CD and go to Measure in Length or Distance. We want to take this measure now and divide it by the radius and multiply it by the absolute value of xb minus xc divided by the value of xb minus xc. This gives us our value of secant theta. So we will relabel this calculation as secant theta so that when we look at that calculation, we will know what it represents. We will now hide our measurements that are not theta or secant theta because our focus is on the values of theta and secant theta. We want to see the relationship between theta and secant theta, so now we will graph the value of secant theta. In order to do this, first highlight our value of theta, then highlight our value of secant theta, then go to Graph and plot this as xy. Now a new point appears on the graph. We want to show this represents the value of secant theta, so we will construct a red segment so we can see how it correlates to CD in the graph. As point B on our circle is moved, the lines on the graph also change. We want to see the shape that this varies at, so we will click on point B, go to Edit, Action button, Animate. Now we have a button that animates point B. In order to see the shape of the secant, we will click on the point that we just plotted that represents the relationship between theta and secant theta, and go to Display, Trace. Now animate point B. Now we will see what a secant graph looks like from 0 to 2 pi. Remember, there is another way to find the secant line. Instead of having a line tangent at point B, we could have constructed a line tangent at point A and construct the rest of the secant in a similar way.